So this was June 2023, Unit 6. Question 3, we did the last. So we'll do question 4. And then after this, I will solve the structure questions from Unit 5 topics and the revision from the book we will do. So in this one, a group of students prepared methyl 3-nitrobenzoate by nitration of methyl benzoate, as you can see here. The procedure 9 cm cube of a concentrated sulfuric acid was added into a small dry conical flask and label the flask as A and it is placed in an ice bath. Usually, why we place a beaker or container in a ice bath, the main is like sometimes the reactions are highly exothermic. So to prevent them, we place an ice bath. 4 cm cube of a methyl benzoate to the flask A and it gently swell. Then mix 3 cm cube of a nitric acid and concentrated sulfuric acid, that is for nitration. And place the test tube in an ice bath, the same thing. The reaction will be highly exothermic. That's why ice bath is used here. Then a flask A, add add the nitrating mixture very slowly in flask A using a dropping pipette. Take care, ensure that the temperature of a flask content does not rise above 15. Because if it rises above 15, then we may have a multiple nitration may happen. That's why we are not increasing a temperature above 15. Remove flask A from the ice bath and allow it to stand at a room temperature. Pour the reaction mixture into a small beaker which contain crushed ice. Allow the ice to melt and separate the solid methyl 3-nitrobenzoate by suction filtration. Wash the solid with a small amount of deionized water and with a little ice called ethanol is there, then recrystallization and then determine the melting temperature of purified crystals of methyl 3-nitrobenzoate. An ice bath is a mixture of ice and water in a beaker. Suggests an advantage of using an ice bath in step 1 and 3 rather than a beaker containing only ice cubes, and justify your answer. Look, when it is having a ice and a water means it will have a temperature, a constant temperature of 0. Another thing, advantage of using ice bath step and rather than a beaker contain only ice cubes. So another thing is that if a beaker contain ice cubes, then the area and the contact for the beaker or a container will be smaller as compared to that in ice, because ice bath contain crushed ice as well. Mixture of ice and water, and what ice bath consists of? It consists of crushed ice. So the advantage of using these crushed ice, because it will have a large surface area, so it will have a greater effect of cooling. So the ice bath contain crushed ice, which increase the surface area, and it will improve the rate of cooling. Side products from it, if the temperature rise above 15 in step 4. So what, as I mentioned, if a temperature is above 15, then multiple nitration may happen or occur. So what might happen, like in this one, we have NO2 is attached here, but what might happen, NO2 might be attached because it can be attached with 2, 4 and like the first position is there 1, 2. These are some of the groups are known as a ortho group, some of the groups are known as a para group. So what might happen, multiple nitration, it is acceptable. Like you can draw NO2 here, you can draw NO2 here. Just the idea is that even if you draw one of them, that is also fine. But the idea is that multiple nitration might happen or occur. That's why to prevent the multiple nitration, we should use a temperature below 15. One student drew a suction filtration apparatus in step 6. Identify 3 ways in which this diagram is incorrect. So this is a bachelor funnel. First thing, what is missing here? The missing is a vacuum pump, because for a suction filtration, there must be a vacuum pump attached to remove the pressure, which reduce the pressure from inside. So it happen quickly. That is one thing. The second thing, so the mistakes here, the conical flask need a side arm. There must be a side arm, and this side arm so that is one mistake. And then they said this side arm must be connected to a vacuum pump. That is another mistake. And as you can see, base of a vaginal funnel. So this is the base of a vaginal funnel is there. So, but this is a base of vaginal funnel, but they did not label any filter paper. So there must be a filter paper here in the base. So when we pass the solution, as the vacuum pump remove the air, so the filtrate can easily enter and the dry solid will be left on the filter paper. So the three mistake, that side arm is missing in the conical flask, the pump is missing, and there is also a filter paper is also missing. Describe the stages in the recrystallization in step 5, stating which stage are required to remove insoluble, and outline detail of a methods are required. So like why we carry out this, you have to learn this recrystallization steps. So first, whenever recrystallization is done, so first thing, we will dissolve the solute in a minimum volume of a hot solvent. That is the first thing. So we'll dissolve the solute in minimum volume of hot solvent. That is first thing. So very small amount of solute we should take, and we should dissolve in a hot solvent. In this case, like because we have to specific about the solvent, as I mentioned, it is ethanol is used. So the hot solvent should be ethanol. That is the first point. The second thing, what we'll do, we'll use filtration to remove the insoluble impurities, and basically hot filtration, so that maximum will remain dissolved. So we'll use hot filtration to remove insoluble impurities. So by using this hot solvent, hot filtration means we can warm the filter funnel with like a glass filter funnel is used, and that is warmed. And the main purpose is why a hot filtration, so the soluble substance remain dissolved and the insoluble substance left on the filter paper. Then the third point, we will cool the solution and it will form a solid. Cool the filtrate. Which will form crystals. And at the last, what we do, we will again, so cool the solution, the precipitate of a solid will form. And then we will do a suction filtration, the last point. So a suction filtration to remove soluble impurities, and it will left behind. And suction filtration remove the soluble impurities, and it will left behind the insoluble, like it will left behind the dry solid which we want. So these are the points you should always include. Then in part E, the crystals must be dried before the melting temperature can be determined. Cannot be dried by addition of a drying agent. Suggests any addition of a solid drying agent is not suitable to dry meats. Suggest why. So what might be a reason why in this case a drying agent cannot be added? Because if we add, like example, this is already a solid, like I want to dry a solid. So if I add any drying agent which is in a solid state, so it will be difficult to separate the drying agent from the mixture, because like we are just mixing two solids. So why addition of a solid drying agent is not suitable, or what is the reason? Because both are solid, so it will be difficult to separate them. State how the crystals of 3-methyl benzoate could be dried. So how we can dry them? We can use oven. We can also use a filter paper. We can use a tissue paper, or we can leave them in a dry place or desiccator, or use oven. In part F, the mass of a dry methyl 3-nitrobenzene crystals prepared by one student is 3.05 grams. Calculate the percentage yield. So percentage yield is a practical value divided by theoretical into 100. We have the practically 3.05. So theoretically, how much we should get if the original amount of the solution which is used 4 is 4 cm3. So this was 4 cm3 for methyl benzoate. This is a methyl benzoate is there. So 4 cm3 methyl benzoate, what is the mass of 4 cm3? The density is given, so we will work out the mass. So methyl benzoate density is given and molar mass is, so density is mass over volume. So mass will be density times the volume. So density is 1.08 and the volume used is 4. This will give us the mass of a methyl benzoate which was used in the experiment. So 1.08 multiplied by 4, it will be 4.32 grams. Now 4.32 grams, and now as you can see, the 136 and 181 is a ratio of the mass. Like if this is 136, if this is 136, this will be 189. So if we have 4.32, as a ratio is 4, so 136, sorry, 181, not 189. As a 1 mole is there, so 136 is to 181. So 4.32, so this will be X. This will give us the mass. So we just cross multiply 4.32 multiplied by 181 divided by 136. This will give us 5.74 grams. So theory suggests we should get 5.7, but practically we are only getting 3.05. So percentage yield is a practical value 3.05 divided by theoretical value 5.75 into 100. So when we multiply, we get about 53% yield. Is it clear? This one? Okay. The last question, the melting temperature of 3-methyl data given is 78 to 80. Suggests a melting temperature range for a sample before recrystallization. Look, when a substance is impure, if it is a boiling point, the boiling point will be higher, but the melting point will be lower. So if it is 78, any temperature range we can mention. So range is there. So you can mention, like example, from because 272 to 76 you can mention. And why we select this range? because before recrystallization, it was impure. And when the substance is impure, what happened to the melting point? The melting point of impure substance will decrease. So it will have a lower melting point than what we have. And another thing, range also increases. Like it's not like two things happen. If a substance is impure, melting point will be lower and it will have a greater range as well. Same thing, if a substance is impure, the boiling point will be higher and it will have a greater range. Like here, the pure substance range was given like from 78 to 80 means 2 degrees. That's why I increases the range as well. So whenever the substance is impure, two things should happen. Range should get wider, and if it's a melting point, it will be lower, and it's a boiling point, it will be higher.